Hello again to Safety Short Series. This is the 23rd video of the series, and today's topic is very interesting, and that is on HAZOP, which is Hazard and Operability Analysis. A Hazard and Operability Study, or HAZOP, is a systematic investigation of a present or planned process of or operation. It was originally designed to assess chemical plants and the procedure and process used in them, but is now applied more widely. The goal of HAZOP study is to identify and evaluate any problems within a plant or work environment that could pose a risk to the employee or equipment. It also looks at processes that might prevent the facility from running as effectively as it should. In addition to helping the plant running smoothly, hazard and operability study also allows safety professionals to identify and then either control or eliminate hazards. HAZOP is ideal for large and complex systems. Breaking these down into their component parts and assessing each in turn gives safety professional more fine-grained look into potential hazards that may otherwise be overlooked. Now let us see what we have in the box today. As you can see, let's start with the definition part. So the HAZOP analysis technique uses a systematic process to identify possible deviation from normal operations, and secondly to ensure that the appropriate safeguards are in place to help prevent accidents. Now this is just the definition approach. The HAZOP technique uses keywords or guide words used by technical team comprising of a system domain or a process expert. Now these keywords primarily talk about first, flow of any material intake, that is, if any material is fed, is it fed or not, what will happen if it's more, less, or it's not fed at all. Now these parameters are site condition and system specific. Here team is applying qualitative approach to analysis theoretically by discussion possible consequence that can go wrong if the desired action is not done. Now combined with the process conditions, which can be defined as speed or flow and pressure, to systematically consider all credible deviations from normal condition. Now these guide words that we use, for each guide word we discuss specific condition that can raise, and finally control recommendations are taken into account. Now HAZOP study mainly gives projection to what can go wrong and what controls we have to ensure safe process operation. Now let's start with some limitation of the techniques. So this is limitation of HAZOP technique. So firstly, it requires a well-defined system or activity. The HAZOP process is a rigorous analysis tool that systematically analyzes each part of the system or activity. To apply the HAZOP guide words effectively and to address the potential accidents that can result from the guide words deviations, the analysis team must have access to detailed design and operation information, that is PNID, process PNID. The process systematically identifies specific engineered safeguard, that is instrumentation, alarm and interlocks, that are defined on detailed engineering drawing. So these are very much basic requirements. So if you don't have technical data inputs or technical information available, then you will not be able to conduct it. So there is a limitation with this, that it requires well-defined system or activity. The second limitation rather, is its time consuming. The HAZOP process systematically reviews the credible deviation and identifies potential accidents that can result from the deviation. Now it investigates engineering and administrative controls to protect against the deviation and generate recommendations from system improvements. This detailed analysis process requires a substantial commitment of time from both the analysis facilitator and other subject matter experts such as members, the operators, engineering personnel, equipment and vendor, all of them. So it is basically a time consuming job. Why we need it? Because we must know what system we are going to analyze. So for that, firstly you should know who is operating the system, so he knows what operation goes when. The second person that is important is the person who is going to who knows the process. The third is what controls are available. So if possible, the vendor or a technical team member from the engineering and maintenance division, that yes, the maintenance guy can tell you, okay, these parameters are available to us. Correct. So that is why it becomes a time consuming thing. Third limitation is it focuses on one event cause of deviation. Now HAZOP process focusing on identifying single failures that can result in accident of interest. If the objective of the analysis is to identify all combinations of event that leads to accidents or interest, more detailed techniques should be used such as fault tree analysis, YY or LOPA, that is layer of protection, CAPA, that is corrective action and preventive action, for each specific system or chain of events or action that can lead to incident. Now why it is so? Because I'll just simplify this. HAZOP basically we are discussing only one event. Right. Now if you want to discuss what will happen, what consequence will happen from if this happens, then what will go wrong? What will be wrong with the surrounding? HAZOP doesn't discuss that. HAZOP only discusses single failure that can result in accident and that is of interest. Correct. Now let us discuss procedure. So the procedure for performing HAZOP analysis consists of 5 steps. The first step is define the system activity. Now this is a very quick slide. Define the system activity. Specify and clearly define boundaries of system or activity for which hazard and operability information is needed. So the very first thing you need to do is you need to define the system activity. The second part is define problem of interest for analysis. Now specify the problem of interest that the analysis will address. These may include health and safety issues or environmental concerns, etc. Correct? Now further subdivide the system or activity and develop deviations. That is, subdivide the system or activity into sections that will be individually analyzed. Then apply HAZOP guide words that are appropriate for the specific type of equipment in each section. Now conduct the HAZOP review. Now systematically evaluate each deviation for each section of the system or activity. Now document the recommendation and other information collected during the team meeting and assign responsibility for resolving team recommendation. Now use the result in the discussion making, evaluate the recommendation from the analysis and the benefits they are intended to achieve. The benefits may include improved safety and environmental performance and cost saving, and determine implementation criteria and plan. So this is how we define, in very simple 5 steps, procedure for performing HAZOP analysis. Now let's see what's further. So now let's understand the practical approach. So in order to understand HAZOP, you require to define some of the terms, which we are, saying that that term definitions, and under this few important things, one is study node, second is intention, then deviation, cause and consequence. So first and foremost thing is to understand these terms and its use. So we start from safety, study node. So the location at which the process parameter are investigated from deviation is called study node. The location, correct? Then the intention. The intention defines how the plant is expected to operate in the absence of deviation at the study node. Here we define idle function, correct? Now comes deviation. Now these are departures from intentions or deviations from the intention, which are discovered by systematically applying the guide word. Defining guide words which one to use depends on what parameter is intended to be studied. Are we studying flow of material, pressure generated due to flow of process, or temperature graph, correct? So that guide word depends on that. Now comes the causes. Now these are reasons why deviation might occur. Once a deviation has been shown to have credible cause, it can be treated as meaningful deviation. These causes can be equipped or can be of equipment failure, can be a human error on an it can be an unanticipated process state, that is change in the composition, or external disruption like loss of power. So these are the causes. Now finally the consequence. So these are the results of deviation should they occur, like release of toxic material, unimportant consequence relatively to the study objective are or can be dropped. So that means that is the starting point. That means you have to find the hazard for what. So similarly in HAZOP, the issue is that a given system where you want to study the deviation, the location at which you study the deviation is known as study node. The location at which you study the deviation. When the approach is systematic means we must first know what we intend to study. What are the possible deviations? What can be, caused due to deviation? And finally, consequence to be known. If you think of a chemical reaction, there you may find out that there the reaction time could of is of an importance there. Uh, the reactor will be in a location at which you are interested to conduct the hazard study and find out the deviation. So that is why the location at which the process parameter are investigated for deviation. So study is for process operation, its duration, where each and every equipment component like every pipeline, each and every valve and its function is defined and discussed for its intended operation, deviation, causes and consequence. Correct? Now let's understand a quick guide to HAZOP. Now divide, the very first aspect is divide the process into sections, that is reactor, storage, operation. What happens and at what stage, step by step. So you have to very clearly define it in a way, okay, step one. Even if you have to define it at a level, okay, if this button is pressed, so the intended function of this button was to operate that valve or whatever. So you have to define it stage, step by step. Now, wisely choose a study node that will include line, vessel, pump, valve. Why? For we will be discussing function that is desired in process. If that intended function is not happening, what will happen? Correct? Now we define or describe its intent. What is intended function parameter? That means with any valve open, what is the intended function? How much pressure, flow, what are the parameters intended, and how we are controlling it, monitoring it, or observing it. Here, it is important to know which parameter are controllable, which parameter are responsible for defining control, and how we intend to monitor it. This means we have a control based on interlinked with some display of gauges that are to be observed, some component function defined based on monitoring limits, and finally controls with set limits. Once this is known, we define or select guide words or process parameter based on intent. What guide word will do? Will say the intent function is not performed as intended. Now, in this case, parameter are guide. It can be more, less, or no. So in case of flow, pressure parameter can be as intended as high or low pressure. Is not increasing. Temperature parameter is also same. It can be high or low. As we put the guide word to its use, what are we doing? We are trying to find out what will happen, which gives us our next point, and that is determine cause. So we in the third point defined intent. Then in fourth point we defined the guide word based on any deviation, and from intended guide word helps us better understand the process defining cause. What will go wrong is described based on qualitative parameter of discussion. Now, cause can be minor, failure of equipment, component, or disaster of product, not being found. Now, based on the cause, we finally get to evaluate and consider action or more control needed, or its reasonable or reasonably level of control exists. That means evaluate consequence or problem. So once, because the cause is finally we know, so what we do is we try and understand whether there are more controls needed there, how to evaluate, what consequence, what will be the recommendation part. Now to conclude, let's take some basic process parameter. So I'll just quickly tell you what are the basic process parameter that we consider in HAZOP study. So basically the parameters are flow, volume, pressure, temperature, time, level, concentration, phase, power, composition, viscosity, agitation, reaction, and component. So each of this parameter can be given a guide word, say flow, so high, low, no. Correct? Volume, again high, low, no. Like similarly, all the components like concentration, so whether the concentration is high, low, or more, no. Correct? So that can be defined. So hope we were able to give you as much information on HAZOP analysis. Thank you everyone for your support. Like I said, Safety Shots is a series focusing on short safety videos. Thank you for all your support. Keep liking and sharing, and do not forget to subscribe for our motivation. We'll keep posting more such videos. Till then, be connected and stay safe. Thank you, friends.